What's up, fellow polymaths? In this video of the Java Fundamentals tutorial, we'll be going over recursion. Recursion means a method that continuously calls itself. Recursion is used to make methods more simple and use less code. The syntax for recursion is basically where you have the return type, such as like an integer, a double, and so on, and then the method name. And then within the brackets, you have the code to be executed. And then under the code to be executed, you call that same method name as well. So that's why they call it recursion, because the method is continuously calling itself. So as you can imagine, a method calling itself might have a potential for infinite loop, and we'll be talking about that very shortly. Just as loops can run into the problem of infinite looping, recursive functions can run into the problem of infinite recursion. Infinite recursion is when the function never stops calling itself. Every recursive function should have a halting condition, which is the condition where the function stops calling itself. So now that we have a brief overview of recursion, let's actually try some recursion now and see what it's like. All right, so we're in the main class right now, and we're going to create two recursion methods. One that's a factorial and one that's a Fibonacci. So first we'll do the factorial method first. All right, so we created our factorial method. It takes an integer parameter, and then the return method is an integer value. So let's go into the main method and then call this factorial and put in a value. All right, so here in the main method, I put out a print line statement, and within that print line statement, I put in the factorial method that we created, and then the argument that we have is the number 10. So try to guess what number we're going to get, or if you have a calculator handy, you can determine what number that we'll get. So let's run this right now. So we have 3,628,800 as the output. So let's verify this with the calculator. All right, so here I pulled up a calculator, and then we're just going to determine if this factorial is correct. And it looks like it's correct, 3,628,800. All right, so just going a brief overview of the code here for the factorial method. So basically what we did is we have a factorial that returns an integer and it passes in an integer number. So the if statement on line 14, it checks if the number is equal to 1. So if it's equal to 1, so that means we're going to stop the recursion. So basically it means that we've decremented all the way down from whatever value that we pass in this case 10, down to 1. So this represents our halting condition, the return 1. Else, if the number is not equal to 1, then we're basically returning the number that we passed in times the factorial method. So this is the part where it's calling itself. So this is very important right here. So this is where the halting condition helps to kick in, because each time the factorial is called, the number that we pass in is decreased until that number reaches 1. So that allows the recursion to stop once it hits that halting condition. So now that we've created a factorial, let's create a Fibonacci method. All right, so I created the Fibonacci method. I made the method a void so that we can have each output on a print line statement. So the Fibonacci passes in an integer number called counter. So first we created 3 variables, which are all static, num1, num2, num3. So initially num1 is equal to 0, num2 is equal to 1, and num3 is equal to 0. So let's run this method and see what the result is, and I'll explain what's happening. All right, so we ran the Fibonacci method. We passed in 10 as the number, and we have our result. So basically we're getting from 0 to 89. It shows as 11 here, but the 0 is ignored in terms of the counter. So let me just explain what's happening here in this Fibonacci method. First, we pass in an integer variable called counter. Then in our print line statement, we print the number 3 variable, and initially it's at 0. So after that, we reach this counter if statement. We check if the counter is greater than 0. And if it is, then we set the number 3 equal to number 1 plus number 2. And since number 1 is 0 and number 2 is 1, number 3 is going to be set to 1. And then in the next line, number 1 will be set to number 2. So that means number 1 will equal 1. And then number 2 will equal number 3, which means number 2 will be 1. So then after that, we call that Fibonacci number again. This time we decrement the counter by 1. So instead of 10, now the counter is at 9. So again, this is going to be the halting condition part. Then we call that print line statement number 3 again, and we get 1. And then after we check the counter again and see that it's greater than 0, so then our number 3, which was 1 before, is now equal to num1, which was 1, and num2, which was also 1. So now num3 is 2, and num1 is equal to num2, which means num1 is 1, and num2 is now equal to num3. And since num3 was 2, num2 is also 2. We keep going, and basically after 10 counters, we get to the number 89. So after that, that counter finally reaches 0, this Fibonacci counter. So then it checks the condition again, if the counter is greater than 0. And since it's not, we go to this else condition, which when you have the return keyword, it means to exit out of the method. So even though this is void, if you have this return, it basically exits out the method. So that's pretty much a brief example of the Fibonacci sequence. Try some out on your own as well. You can also design the Fibonacci method in a different way than I did. There's different ways to design the Fibonacci method. All right, here's our assignment for this topic. Number 1, what is the definition of recursion? What is the purpose of recursion? Number 2, what is the purpose of a halting condition in a recursive method? Number 3, create a recursive factorial method and pass in the number 15 in the factorial method. What is the answer that you receive? If this video was of any value to you, then please leave a like, comment, share, and subscribe. Thanks for watching, and I'll see you later.